Let's take a look at Ernie the Exponential, Part 3. f of x is equal to x squared times e to the x. Now this looks like a pretty complicated function, and it was. It took the product rule for us to figure out what the first and second derivatives were. There was some pretty unique factoring that was going on that involved the quadratic formula. It was pretty cool. If you're interested in it, go back to parts 1 and 2 or to the readings to see exactly how we found out these critical values of -2 minus root 2, -2, -2 plus root 2, and 0. I used the information from those previous parts to put together a double sign test with f prime and f double prime, and used the lovely chart here to tell us what shapes were going on. There's only one root to this function. That would be at x is equal to 0, since e to the x is never 0 for real numbers. There's also a horizontal asymptote, and that's key. Students oftentimes miss the fact that there's a horizontal asymptote for this function. It would be at y is equal to 0. And the reason for this is the limit as x goes to negative infinity of x squared times e to the x acts like the limit as x goes to positive infinity of x squared over e to the x, and that's because of our wonderful properties of exponentials. We're going to use all of this information to see what's going on. You can kind of see a little bit of it here. We're going to have our function level off, but be concave up. It'll increase, have a point of inflection, reach its maximum, go back down to 0, where we're going to hit the origin and a relative minimum, and then increase forever thereon. So, what are the important ideas for this function? We have a relative maximum when x is equal to -2. Two ways you can prove this. As always, f prime goes from positive to negative, or you could show f prime of -2 is equal to 0, f double prime of -2 is less than 0. That's our good old-fashioned second derivative test. And you can see from this information here that that's true. Derivative goes from positive to negative, second derivative is negative. At x is equal to 0, we're going to have a relative minimum. F prime goes from negative to positive, and f prime of 0 is equal to 0, f double prime of 0 is positive. Both of those things, either one, could actually prove that we've got a relative minimum and x is equal to 0. Looking back at our tests, we can see derivative goes from negative to positive. Second derivative is positive at x is equal to 0. Putting all of this together, we start with our horizontal asymptote of y is equal to 0. The function is going to have that concave up increasing quality to it until it gets to the point of inflection at -2 minus root 2, which is somewhere between -3 and -4. The function is then concave down and increasing, which we can see by that little subtle shift right there, until it reaches its relative maximum at x is equal to -2. When you plug -2 into the function, you get 4 over e squared, which is a number that's slightly smaller than 1. Okay, and then the function decreases and is concave down up until that point of inflection of -2 plus root 2, which is a number that's slightly between, or it is between -1 and 0. The function is then concave up and decreasing until we reach the minimum at 0, 0, and then the function goes off to infinity. An interesting little function. Looks boring to begin with, but when you zoom in right around these points, right between -4 and 0, you got a lot of action going on with this polynomial. Not polynomial, this polynomial times an exponential.